Hi everybody, and thank you so much for joining us for today's webinar. Today's webinar is called Acoustics 101, Introduction to Noise Management, and it's all about noise. The noise is something that impacts our day-to-day lives, whether it's traffic noise, noise from a train, from planes, or from an industrial plant. But we probably don't think much more about noise than just that, how it impacts us. But it's the WHO says it's one of the factors that's increasingly important for us to consider for people's health. So we're lucky joined by Dan Clayton from SLR, who's going to talk us through how we assess and mitigate noise in Canada. My name's Hannah Williamson, and I'm going to be moderating today's webinar, and I just want to run through a couple of housekeeping points to make sure that we can run today's session runs smoothly. First of all, please check your audio settings. So all of our participants on the line are muted. If you are having issues hearing us today, please use the chat box and select questions for staff, and we'll do everything we can to resolve your issue quickly. One tip I will share right off the bat is that if you're experiencing difficulties with the audio or hearing us, please try dialing out and dialing back in again, and that normally fixes about 90% of issues. Questions are encouraged, and there's no such thing as a stupid question. So if you have questions for today's presenter, we're going to have some dedicated time at the end of the presentation. Again, use the chat box and select questions for staff. If we don't have time to get to your question, we'll take that offline and send it to Dan after the call ends, and we'll get you an answer. Today's presentation is being recorded and will be made available to you on demand. So you'll receive an email within 24 hours, and it's also going to be available on the Eco Canada website. And finally, we really want to know what you think about our series today. So if you have any comments or feedback, you'll get a link to join a survey just after the session ends. Please let us know what you think about today's presentation or about future topics you'd like to see us host. Today's session is brought to you by Eco Canada. Eco Canada is the steward for the Canadian environmental workforce across all industries and sectors. We champion the end-to-end career development of environmental professionals. Not only do we certify and train, we also carry out in-house research to understand where the challenges and opportunities are in the Canadian environmental workforce. And we use that information to tailor our services and our programs to you, the professionals working in the sector. All of our efforts here at Eco Canada are geared towards driving sustainable, responsible economic growth. Now, without further ado, I'm going to introduce you to today's guest speaker. Dan Clayton works for SLR Consulting. He's got over 12 years experience conducting a wide range of acoustical assessments, both in Canada and in the United Kingdom. He's experienced with the oil and gas sector, mining, architecture, transportation, construction, demolition, and carried out projects across all these different fields. And Dan is an advocate for increasing public awareness around noise and its impacts. Welcome, Dan. Thanks so much for joining us, and I'll hand over the reins to you now.
Hi everyone, thanks so much for joining us. So I'm going to take you through a bit of an introduction to acoustics in general and a specific focus on noise management. So a little bit about who I am. Hannah gave a nice little introduction there, but I've worked in the industry for about 12 years, did an acoustics degree, so I went straight from that into the industry. And I've worked in various sectors, power, mining industry, all these sorts of things. And I have a little bit of a side project, which is an acoustics show called Noise Busters, where I'm trying to create awareness. So this is just part of that. I work for SLR Consulting, but I'm in Calgary, but we have offices globally. So feel free to email me or check out the website there. So a little bit of an overview of the presentation. So I'm going to go through what noise is, the types of sound sources that you might come across, the health effects associated with noise, a specific environmental noise focus with an assessment in Canada kind of angle, then delving into a rule book for good noise management and some typical noise control measures to help you out if you're in that situation. So a brief intro and SLR. So we've got various offices across Canada. I'm in Calgary, pretty much Western Canada, and we've got offices worldwide. So we've got all sorts of things, and I fit into a larger acoustics team, about 100 globally, so we can look after all sorts of things. There's some wider services that we do as well, so it's quite cool to be part of that, where you get to learn about all different industries and different types of people doing things. So whether it's air quality, environmental approvals, renewables, greenhouse gas, anything to do with water, ecology, geotechnical, we have a big mining division now, or anything to do with environmental design we can take care of. So into the meat of the presentation. I'm going to get across an introduction to acoustics, so have a definite focus on environmental sound affecting humans, Acoustics is a broad subject, so I'm going to have to keep it succinct just because it's so broad and I've not got a huge amount of time to go into that much detail. So if you have any questions about occupational noise, vibration, structure sound, underwater noise or noise affecting wildlife, please email me and I'm happy to help further on that. So let's talk through some typical sound levels, because we often get the idea that there's decibels of floating around and we don't really probably understand what they mean and what they relate to. So this little picture here on the right gives us a good idea and a range of different sound levels that correspond to things that you can relate to. So sound pressure initially is a unit of pressure, which is basically the fluctuation of the atmospheric pressure, so just normal pressure, when a sound passes through it. So a sound wave propagates through it, it changes the pressure, and that's what we call sound pressure. We can then equivalent that into a sound level, which is what you hear as decibels. So that's a logarithmic representation of that pressure. And we'll go into that into a little bit more detail later. So this little picture on the right here, you can see that the lower the level, i.e. 0, the quieter it is. So we can go right from a quiet picnic area into a living room in the kind of 40 decibel region, which is the same as kind of a library. Offices then get a bit louder, kind of the 50 to 60 region, and we're getting to the speech levels. And then workplace noise starts around 70, pushing to around 100, and we can hear that kind of outside near to loud buses or trains. And then we get to the louder levels where we need hearing protection for rock concerts and using pneumatic chippers. I don't know how many people actually do that, but it's an example thrown around a lot. And then we get to the really high level stuff, which is if you're stood close to a jet engine taking off, which I have done to measure noise. It's really loud. I don't recommend it. But that's the kind of level, upper level, and we class that as the threshold of pain. So that's why we're up there. So the human ear has a range, the dynamic range, which is this volume thing, from 0 to around 130 for that reason. So 0 is where we can't hear, below that, and then 130, 120 is where it starts to hurt. So there's some indices that get thrown around. Sound power is one, which is essentially the decibel level from a source, and it's the sound that's emitting from that source. So it's not what you measure next to the source, it's the actual sound that's being radiated by that source, i.e. a fan or your voice. It's actually the power of it. So it's measured in watts. And then sound pressure level is what we would measure. So often you would get that as a measurement level, so many decibels at such a distance. So the easy way to tell the difference is that a sound pressure level is measured at a distance from something, whereas a sound power level is a calculated value from measurements around it. So let's debunk decibels a little bit. So I talked about hearing dynamic range. So it's a logarithmic scale. That's why we use decibels. So we do log of the pressure. So a decibel is related to a value, i.e. the sound pressure, over a reference. And in the case of sound pressure level, it's the measured sound pressure over the reference sound pressure. So the reference sound pressure corresponds to the threshold of hearing. So that's the level that we start to be able to hear something as a consensus. There was tests done and that was the kind of level. So decibels can be a bit confusing because when we add them together, we can get a bit lost. So let's talk about changes in sound level just initially. When we talk about changing sound level, it takes a small number to actually be a drastic difference. So when we get to a change in 3 decibels, so an increase or a decrease, that's actually just noticeable by a human. When we get to 5, that starts to become noticeable. When we get to 10, which isn't actually that big a change as a number, it's actually twice as loud, perceiving that sound level change. 15 is a huge change, and 20 is actually 4 times as loud. So you can see that your small changes actually mean a lot. If you say, oh, it's only 3 decibels bigger or 5 decibels bigger, 10, it's actually a big difference in decibels because of the log scale. So doubling of sound energy equals a 3 dB increase. So for example, if we have 2 sound sources of the same sound level added together, it's 3 dB more than the one alone. So that doesn't make a huge amount of sense unless you're familiar with logarithms. So 65 dB plus 65 is 68, not 130. So if you kind of get that, sink that in a bit. So a 10 dB increase is a doubling of loudness, but actually a 10-fold increase in sound energy. So you can see that understanding decibels is really important to understanding how the actual levels relate to reality. So the other aspect of this is that there's a frequency content and an aspect to the sound. So we measure that in hertz. So you may have heard that already. So that's the number of oscillations per second, and we're talking sound pressure here. So if you imagine a washing machine that spins and gets faster and faster and it goes higher in pitch, so that's a good example of the frequency changing due to the speed. So it's rotating and getting this kind of increased frequency. So humans actually perceive frequency logarithmically as well, which is interesting that we have that kind of auditory system. So the lower the number frequency, so i.e. 10 hertz, is way lower in pitch than 1,000 hertz. So that's how the numbers work. And a young adult can hear a frequency range quite large. So it's 20 hertz to 20 kilohertz, 20,000 oscillations per second. So as we get older, that starts to degrade and knocks down over time naturally. I've probably got a bit more from being in rock bands and things, but that's how that kind of degrades over time. And we're most sensitive in this 2K to 3K region because that's speech, and we've kind of historically had that as kind of an alert and a warning thing when we were Neanderthals and things. There's a few brackets of frequency of sound. So there's infrasound, which is your kind of earthquakes, low vibration kind of sound, 0 to 20 hertz. Low frequency sound is 20 to around 200. Mid frequency is 200 to around 1K, maybe a little bit higher. And then high frequency is this kind of 1K to 20. And I really implore you to go and dig into how those sound. But basically, they kind of equate to the bass, middle, treble on your hi-fi. You can kind of hear like a hiss is a high frequency noise, and a bass guitar is in that low frequency region. So we use frequency ratings to kind of make this a bit easier. So when we measure with a microphone a sound level, it comes through unweighted, and it is as it is. So it's measured as like just a level, a voltage level. But we can apply weightings to it to make it more realistic to how we actually sound, hear things. So humans actually perceive low frequencies and very high frequencies less sensitively. So we have this weighting applied to a microphone that basically takes account for that, so we can express that as a single level to make it more realistic to how we perceive things. So you can see this chart on the right demonstrates that with the blue line. So we can actually have another weighting called C weighting, which is actually designed for when sounds get really, really loud, the hearing system actually compresses and flattens this curve so we hear sound more evenly. And this is actually used in Canada and North America mainly for a comparison between low frequency to see if there's a presence of low frequency sound. So if you take the A weighting level broadband from the C weighting or vice versa, you get a difference. And if that's a large number, say 10, 15 dB, pushing 20, then that might show that you've got more of a low frequency presence because of this difference in the weightings. So Alberta and British Columbia are the only ones that actually use this in Canada. So let's delve into environmental considerations like outside stuff. So when I think of a sound source, the things I like to identify are the level of the source, so the sound power that's coming from it, the type of sound, i.e. what it sounds like, the frequency content, or if it has any characteristics, or the directivity of the sound. So is it pointing in a certain direction? Is it louder, like a plane, for example? It's louder at the front than at the back. We need to take those into account because it makes a difference. So that you've always heard that thing that if a tree falls in the forest, does anyone hear it? We need to identify where the receptor is. Is there a receiver? Do we care? And then we need to know how far it is because sound dissipates with distance. Is there something in the way? Do we have line of sight of it? Is there a wall in the way or a berm or some kind of bund, earth kind of screening? And next from that, we need to look at how sensitive our receiver is. So that means, is it an office? Is it a school? Is it a house? All these things play a factor as to how sensitive things are. So, and also the operating time. So is it the daytime, evening, nighttime? Because they all have impacts on how sensitive we are. One thing that's quite often overlooked is how the existing sound levels compare to the new one. So we need to really quantify what the influence is from other things like cars, planes, industrial things, and see what's actually like, and then compare that actual level that we've got from our new source, existing source, to the existing sources. So there's a few things that play here in environmental effects. There's dissipation from distance, so inverse square law applies. There's atmospheric absorption, which is from the actual air, the humidity, etc. The particles in the air actually cause a loss, more at the mid to high frequencies. There's ground attenuation, which is different for different conditions. So snow, grassy, if it's sandy, or just bare, makes a difference. Barrier attenuation, so that's line of sight again. And then temperature gradients make a difference. So if we've got an inversion or the opposite, we actually get different effects where the sound can actually travel further and give shadow zones, etc. in this image to the right. So the actual temperature can make a drastic difference. And wind effects. So the wind direction makes a big part. So actually downwind is often the worst case condition. And we also get the shadow zone when the wind is blowing away from us. So it's very interesting. So some indices to play with. So an often commonly used one is LEQ, which is basically an average. We get this time varying level, as you can see with the blue line. It's crazy, it's all over the place. So we want to get an average to kind of give us an idea of how much sound energy is in that over that period. So this is one that's used a lot to kind of represent that. And then we get things like in Canada, the impulsive sound level, which is this LI, which is more for like single bursts in energy or pressure pulses, like blasts or bangs or crashes. And we can actually use that to quantify that. And in Ontario, we have the mean impulsive sound level, which is actually an average of these impulsive sounds to try and give a bit more context to how often it occurs and how much energy is in that. So LEQ is great for continuous sound, but it's not really great for other more fluctuation sounds. So it's used a lot here in Canada, but actually sometimes other parameters are more suited. So other parameters such as LI, LM, Lmax, and L10 are much better for these more time varying and instantaneous sounds. So there's lots of metrics used and assess different sounds and situations. So it's important to know you're using the right one because it's not just one size fits all. So sound characteristics. So the characteristics of sound, they really include a few things. So there's level, frequency content, if you think bass, mid, treble again, tonal characteristics. So has it got a hum, a honk, a kind of a buzz? Tonal characteristics are really important. It makes things much more annoying. So there's a rise and decay time. So how quickly does the sound come? How quickly does it go away? Intermittency as well, and impulsivity. So this is basically, does the sound come and go? We are a lot more situated and able to adapt to things that are constant. If things come and go or change rapidly, we don't like that. So all of these factors make a sound subjective and more annoying. Even if the sound level is the same as something that hasn't got these characteristics, it's more annoying. Like, it's more annoying. We need to get rid of these characteristics if we can. So I think we should do a little quick poll here. So I'm going to play a sound. There's two sounds, and I want you to do a poll that will pop up and let me know which one you find more annoying. So here we go. Okay. So Hannah, have you got the results when they come in?
So I've just launched the poll. We'll give you guys about 20 seconds just to answer, and then we'll share the results. It's great. Just about 5 more seconds now, so get your answers in. Okay, I'm going to close the poll, and let's share the results. So 79% said sound 2 was the most annoying, 21% said sound 1.
That's interesting because sound 1 was a waterfall and sound 2 was a piece of construction equipment reversing with a really noisy, irritating sound. So it's interesting to hear that people found 1 and more annoying. And I know it's done through the internet and stuff, so it's not a true representation, but it just kind of shows that more people find the more intermittent changing kind of sound more annoying. So that was the kind of point to get across. Okay, right. So let's go into what noise is, because this could be confused. So noise is defined as unwanted sound. So it's different to just saying sound. So it's something that causes annoyance because we don't want it, something that causes health effects, and it's a pollutant. So the difference between sound and noise. So sound is measured, it's objective. It's what we get from the microphone, it's decibels, it's what we assess. So the word noise has a subjective connotation and it's linked to annoyance and has a kind of, it's an opinion on it basically. So we know that it's unwanted, we want to get rid of it or kind of control it. So why should we care about noise? So it affects quality of life and health. High sound levels cause permanent hearing damage, and it affects communication, safety, and wildlife behavior. I'm not going into that here, but it's something to be aware of. So what are the worst offenders? So these are some common sources, and you'll probably relate to a few. So transportation noise, a mix of road, rail, air, and sea, especially in Canada with trains, a big source of noise here. Industrial noise, so waste, recycling, manufacturing, oil and gas, etc. Mining, they tend to be further away from people. Still, things like aggregate sites can be close. Power generation, transmission, entertainment venues, so rock concerts or pubs that live down the road, or clubs. Construction noise or domestic noise, i.e. your dog next door or the snowblower, etc. So there's lots of space in Canada. We don't need to worry about noise, right? Well, the thing is, houses are being built closer to infrastructure and development, and vice versa. We're seeming to do that because people need to be near these things. It's expensive to resolve retrospectively due to these things. Increased public awareness, causing more headaches for planners and operators. The assessment and legal process is lasting a long time because of these issues. And mitigation actually makes it more difficult to operate sites. So operating hours, flexibility, and types of materials that can be processed really can change even with just noise factored in. So all of these things can be reduced or avoided just with careful design. When we think of noise health effects, actually, noise is probably more serious than most people might think. It's actually the second largest environmental factor leading to disease burden, second to air quality. That's what the World Health Organization have said. So it's quite surprising to probably a lot of people that I speak to. Some of these health effects may be obvious and some might not. So there's hearing loss is the most obvious to come to mind. Tinnitus, which is related to that, where you get like a ringing in the ears or a change to your hearing system. Cardiovascular effects, so you actually get heart problems. So hypertension, high blood pressure, vascular inflammation, and risk of strokes, they increase. Stress, which actually induces lots of the above. Diabetes, in fact, obesity because of the worry and due to these noises, increased birth defects as well, and child cognitive development. So they're all related noise health effects, which maybe you've heard of some, maybe not others. So I'd love to hear who thinks they have been affected by noise in their life, Hannah. What's the poll?
Okay, so just launching the poll right now. Again, we'll give you guys 20 seconds. Let us know if you've been affected by noise, and then we'll share the results. Okay, about 5 seconds left, everybody. Okay. So overwhelmingly, 86% of people are saying yes, they have been affected by noise, 14% saying no.
Interesting. So that's kind of what I expected. It's noise is a big effect on people. So I wanted to link that to the World Health Organization. So this is a table. I'm not going to go through it in loads of detail, but it's kind of giving you an idea of actually how low the levels are for the onset of critical health effects. So these are for say sleep disturbance, a level of 30 decibels inside your house is actually shown to provide issues during the nighttime. And even speech intelligibility for the daytime is only a level of 35, and then the kind of levels kind of jump around for different types of environments. So it's interesting because the levels are quite low. So 86% doesn't surprise me. Noise affects people in all sorts of ways, and we could talk forever about the different ways that is. But let's dig into assessing sound in Canada. So there's actually a huge variation across provinces and based on the source type. It's normally dealt provincially or at a city level. Federally, there's some stuff, but it's generally provincially. So I'm going to give a brief introduction and taster to the noise regulations and policy in Canada. So there's a few slides that follow, and I'm going to send the presentation out to everyone so you can kind of dig into this further because there's too much to cover. It's such a wide topic, but if you have any questions at the end, please ask. So there are bylaws, which are the local laws in the cities. So yes, noise is typically discussed within bylaws, but they exist and sometimes specify sound level limits or guidance, but not always. They generally don't. They're generally quite open-ended, don't give you much to go off. They're not in line with the current understanding of sound effects in most cases. They're kind of a little bit out of date, and they're more suited to residential sound, so i.e. making sure your neighbour doesn't bother you with the lawnmower or snowblower or those sorts of things, rather than being from like industrial sites. The limits are too high to me for considering the impact of a sound on the acoustic environment. So let's look at some example bylaws. There's loads of bylaws in Canada, but I picked kind of a range, a choice of 3. So I picked Calgary, Victoria, and Ontario. So I've taken the lowest limits of each of them just so there's a direct comparison. So as you can see, there's quite a swing between Calgary and Ontario. There's a difference of 20 dB for the daytime. And as we know, that's 4 times as loud. And just for context, for 65 dB in the daytime, if that was to be in your garden, the level, or wherever you are, you would struggle to speak to the person that was relatively close to you. So that's giving context to how loud that is. For nighttime, 50 dB outside is quite high. As we can see, we get a loss of around 10 dB-ish for a window that's open. So we're getting levels that are 10 dB above where onset of health effects are. So we're saying that that's okay before it becomes an issue. So Ontario have much lower levels and Victoria's kind of in the middle. So 40 dB for nighttime, which is much more reasonable in line with the World Health Organization guidelines. It's just so something to get your kind of brain thinking on that, really. There's a high variation, as you can see, so there's no consistency in approach. So federally, there's a few things, but a lot of them relate to generally occupational noise. That's the main one that kind of is legally in place. There's a few guidances, so there's Transportation Act for aircraft noise management regulations. There's a kind of an angle on that. And then Health Canada has a lot of guidance documents for wind turbine noise, environmental assessment kind of guidance. That's more for EIAs, but has some useful stuff on health effects and quotes the WHO stuff. And then you've got the underwater stuff, at the bottom for Species at Risk Act, Oceans Act, and Fisheries Act, because that's becoming more of a prominent thing here in Canada because we've got the wildlife that likes to share the coast. So some are legally binding, some are referenced, and some aren't even used. But they are used when there's no regulation sometimes, but there's no kind of consensus. It's very much down to the practitioner around case by case. So here's a quick summary of the kind of provincial. Alberta has a good spread of stuff, but they're very industry focused, so not they don't cover all industries. It's very much oil and gas or utilities, power, that kind of thing. Industry isn't covered. You've got occupational stuff in all of these. BC is similar to Alberta, but slightly less regulated. And then the provincial, moving to the Northwest Territories, they start to just switch to occupational with a little bit of an angle on environmental noise. So not a huge part. And then, sorry, Ontario just got missed out there. So Ontario has got a good spread of stuff, and they don't really deal with frequency content now. So that's one thing that slightly lacks. But it's kind of provincially, it's okay, but could be improved. So there's a huge variation as a takeaway. Bylaws and policy, it's huge. Regulations don't cover all instances. You need to be careful. The actual sound level limits in there are relatively high compared to other policies in the world. The average sound levels are used in many cases, but as we discussed before, they're not always the best indicator of effects. It can be specific to source type. And there's a mix of good practice that could be improved. Health effects are actually rarely discussed and considered. There are in the Healthy Canada guidance, but it's not used day-to-day provincially. And this is an important point. Compliance with regulations doesn't actually mean that there's no potential for complaints or impacts. You can meet the limits and still have a nightmare as a site operator or an individual. It doesn't mean that everything's going to be okay. It still needs a good pragmatic approach. And it's important to dig deeper than regulations to actually understand those issues, understand what parameters we're needing to use. It's really important. So we'll have another question here because it just leads into the next section. So I'd like to know who deals with noise in their job, just as an interest as to who I'm talking to.
Okay, so we've just launched the poll. Again, please select the answer that applies to you. And we'll give it another 10 seconds or so. Okay, gonna close the poll now. And 70% saying yes, they deal with noise and its impacts as part of their job, 30% saying no.
That's interesting. So yeah, that's quite surprising. I didn't think that'd be that many. So yeah, noise can be a pain. If you deal with it in your job, you know that it could be a nightmare to deal with, and it causes lots of issues, and sometimes you don't understand where people are coming from. It can be a big issue. So I'm here to give some help as to what is a good flow through of how to deal with management of noise. So as a mantra, relying on complaints is not a good idea. That's often where we go, and that means it's a problem. We need to be proactive and not reactive, because once someone hears a noise and they're bothered by it, they hear it a lot more noticeably. Even if you attenuate it the same amount you would do before they complained, they would still probably be able to hear it because they're always listening out for it. It just becomes more, they've habituated to it, they know it's there, and it becomes more annoying. Not always, but that is often the case. So we need to be aware of what the sound is like at the noise sensitive receptors, both with and without your sound sources. So we need to quantify exactly what the sound is like without your source operating, because then we know how prominent it is. If we don't know that, then we're kind of just pushing around at limits, which actually might not be appropriate, because if we're introducing a really loud source compared to a very quiet environment, then that's an issue because it sticks out more, and that is more linked to annoyance than anything else. So we need to be aware of how that background sound, i.e. without your source, changes over time, because at night it will be quieter generally and daytime will be louder. So we can actually optimize and change sound sources to operate during those different periods depending on how loud they are. So it's important, as I said before, to not design or mitigate to noise limits. We need to actually design to preserve amenity and generally just make everyone's lives easier. So in terms of assessing a sound source, this is my kind of rule book as a good practice, what we should do. So initially, I would recommend doing a model of the sound. It doesn't have to be anything too detailed, just an initial kind of quick model. Calculations are quite straightforward as well for a practitioner to do. So we can come do that. Then we can assess whether this sound source actually has the potential to be a problem. So if the levels aren't ridiculously high or far from receptors, we just go, right, this isn't actually going to be a problem. We don't need to go any further than this. But if there is potential for that, then we need to start actually engaging the community, talk to them, let them know what's going on, what we're doing about it, and explain the process. I've dealt with many sites over my time, and the ones that don't do this always end up worse off in terms of a consultation and public reaction. Those that do actually often get the public on board. So actually, after that, we should undertake a survey of the existing sound level at receptors. Then after that, assess the differences between those two levels and any criteria that might apply just for context, and then control the sound as far as we can within the context. So there's no point controlling loads and loads if there's no receptors around. We need to do it within the context of it. So this is a quick snapshot of a model I've worked on before. This is a good little practice that goes on in Alberta, which is all of these companies come together to pay towards a model, and it updates every couple of years. And it's just an ideal way of checking and seeing how things are changing over time and like optimizing things. So this is a regional kind of noise model, which is a really good way of managing noise. Actually, it's a good way of doing it. So let's get into the detailed stuff. So control measures, I'm going to outline a few different types. So there's three ways of thinking about it in my mind. There's the source, there's the pathway, and there's receptor controls. So always I would recommend that we opt for equipment with low sound power levels. Pick the lowest you can go with. And then what we do is reduce operating demands. So if it's a fan, for example, spin it as low as you can, or make them kind of larger diameter units so that they don't have to spin as fast and move a similar amount of air. So actually optimizing the source, the actual equipment, is often the cheapest way and the thing you can control the most initially. After that, we kind of need to make sure that we're removing and reducing any sound characteristics. So any of these hums, tones, intermittencies, all these sorts of things we can start to tweak and change. After that, we need to look at optimizing where we're placing the sources. So away from sensitive locations is always key, including mobile machinery routes, because we can overlook actually the traffic on site, but the amount of times I've had to reroute things or put barriers in place for the actual routes of mobile equipment, I can't remember how many times. After that, external equipment at ground levels is a great idea. So often we put things like stacks have to go at height, but there are fans that often go at height, but we can actually often get away with putting them at lower ground levels because we naturally use the screening of the building more doing that. So for specific sources like road, rail, kind of infrastructure projects, equipment speed limits or like speed limits of actual traffic play a big part. They actually influence noise level quite a lot. So we can actually introduce systems to control this because actually you find that people go faster than the speed. But the problem in there is that people like myself have designed a mitigation to go with certain speed limits. So if they're going faster than that, that's actually increasing the sound level and not doing it as designed. So the impacts are actually greater than we've designed to. So actually having control measures in place. I know we don't like speed cameras, but it's actually something that's critical for noise. So what we need to do then is optimize the operation of key sound sources during less sensitive periods. Can we operate in them during the daytime? Do they have to be on the whole time? It's something that has actually changed a lot of impacts over the years when I've worked on assessments. When we look at construction projects, for example, or freight rail movements, shunting, we can actually look at using alternative warning systems because if you've ever lived near a construction site or anything like that, you can always hear the reverse alarms like in that example. And as you see, like a high percentage of people are annoyed by that thing. So we can switch that out for personal vibration alarm systems. So it's a little thing that goes in your pocket that buzzes. And we can remove the need for external sounders. But if we have no option for that, we should really be switching to these lower sound level reverse alarms that have broadband character. So they make more of a kind of noise. They're much quieter and less annoying. And just switching those out have actually made complaints go away from sites that I've worked with. One big thing that's overlooked is operator training. We need to actually minimize operational sound. So is your worker able to operate quietly? Are they switching engines off when they should do? Are they banging equipment? Are they dropping equipment from height? All these things make a difference. And then one thing that always gets overlooked is the regular maintenance. The amount of times I've been out to a site and looked at the fan and gone, well, this fan probably was okay about 15, 20 years ago. It's time to replace it. Regular maintenance and keeping on top of equipment is the thing. The amount of times that residents pick up on noisy equipment and it's just that they've gone past the state of repair is quite baffling, really. The last thing that we should really be doing, and the thing that we maybe think about first, is enclosing the equipment using buildings, acoustic blankets, or extra equipment like silencers, duct liners, acoustic levers. They are really the last resort. We should do all of the things above before we even touch anything else. So pathway. So what I recommend is we use topography. We can either shape with the buildings, infrastructure, or screen sound sources using bunds, etc. We can reorientate proposed buildings or infrastructure using the model and kind of get an idea of what layout's going to work best before we even build something. That's a really cheap way of doing it. And then we can actually locate sources in cuttings. So trains can go in cuttings, roads can go in cuttings, or we can build berms and remove line of sight from the land that we have. So we can reshape the land and actually use it to advantage, which is a relative cheap thing. It's just a guy with an excavator half the time. And then the last thing really is temporary or permanent acoustic barriers. So for construction projects, we can actually use temporary barriers that go up like this picture here, or we can use more permanent ones like you see at the side of a road. But they make such a difference to things, and but they are the most expensive. So the other ones tend to be the ones I would opt to recommend first. So in terms of control measures at the receiver, what we should do is, if we have an option, if we're building a new housing development, we should really be putting receptors as far away from existing sound sources as we can. In Canada, we try and segregate them as much as we can, but they're starting to creep closer together and starting to kind of fail in that respect. So moving on from that, public consultation, education, and continuous dialogue with all of the residents around the project can have such a positive effect on the way and the outcome of a project decision. So you can actually involve your residents and get them involved in discussions and let them know what noise they would particularly be bothered around and what their concerns are, and help them understand how loud things are going to be. A lot of the confusion and issues come from just not understanding what things are going to be like. And there's things you could do now like virtual reality, spatial audio demonstrations, which I've worked on before, which help people understand how things are going to sound. So when you actually become operational, the awareness to the public about actual high noise events like blastings or steam releases or construction activity, explanation of what you're doing and how you're trying to mitigate it just makes you come off better and makes the public more on your side. One thing that's quite new is at the receptor, we can start to introduce pleasant sound sources like waterfalls. I know not everyone found it pleasant, but waterfalls, and actually introducing bird song or trees, etc., to try and make this more pleasant environment that starts to mask the sound that's bothering people. So that's a relatively, well, it's not that new really, but it's starting to come into more place in the technical assessment world. And then the final thing is really looking to do acoustic upgrades at properties. So glazing, ventilation, berms, fences, all these sorts of things that apply to the receptor should really be the last resort. We should be looking at that last. So to summarize the presentation, we've learned what sound and noise are, how we perceive sound, how does the auditory system work, how do we assess a sound problem, what are my kind of recommendations, a brief introduction to Canadian guidance. I urge you to go and read that and dig into that. Steps for effective noise management, and yeah, that's kind of it really. So feel free to contact me. My email is here and I'll send the presentation around. Email for the company, and I have a Noisebusters show, which I mentioned, which is me and my former colleague who do a little YouTube show about noise to help people get educated. So, and there's a podcast version. So thank you so much.
Thanks, Dan. What a great presentation. And, you know, as you say, noise, we could see from that poll, affects so many people, and there's a lot of science and physics behind it. So yeah, really thorough presentation. We're now going to have some time for questions for Dan. So please use the chat box, select questions to staff, and we'll read those out. I'm going to hand over to Laurel, who's been managing the questions we've got so far.
All right, thank you. So our first question here is, how do I know if I need to carry out an acoustic assessment for my project?
Okay, well, mainly that you'd look to provincial guidance initially, see what's in there provincially. Generally, that will give you a steer. If there isn't kind of any regulation of your industry, I would recommend just proactively seeking guidance from, just have a quick call with a consultant. It doesn't cost you anything, they can kind of advise you. But outside of that, you can dig into Health Canada, have some guidance that can help you understand more about different types of sources, and just look outside. If you don't have regulations in your province, look to Ontario, Victoria, whoever, and just kind of get a steer from there.
Thank you. Our next question here says, where can I find out more information about acoustics in Canada?
Acoustics in Canada. So I would go to a good kind of grounding in acoustics is there's the Health Canada guidance for environmental assessment for noise. That's a really good kind of introduction for Canada. I have my presentation, and I'm not plugging the presentation, but it gives a good summary of all the regulations. So the Alberta guidance is quite good in terms of assessing different types of sound source, and gives you a good kind of walkthrough of what different terms mean and all that sort of stuff. But yeah, you could talk all day about things. There's also the Acoustical Association of Canada as well. So Google them. There's a few things you could find out, and there's a North American one as well. So.
All right, our next question here is, do you have a mobile device to measure dB?
Yeah, so what's used is a sound level meter generally. So that actually has a microphone on the end of it, and it converts that into voltage and measures it in decibel levels. There's various complexities of those. So you can record audio at the same time, do analysis on the audio, or you can do a frequency analysis of the sound itself coming in. You can log it over time, do real-time measurements, and you can actually get things that go on the web now that you can sync up through your cell phone and get real-time things at site that you're not even there. So that's making and changing the whole way we do the job. So yeah.
Thank you. Next question here says, is a noise assessment a required part of an environmental impact assessment?
Yes, generally it's considered. So the way impact assessments work, my understanding is that you have to do a consultation piece where you actually decide what the guidance you're going to follow and the structure of the assessment is. So generally noise is discussed. It's discussed in the guidance from Health Canada and of the impact assessment guidance. So you would have to follow generally what regulations apply in your province, follow the kind of local guidance that's there. And then there's also guidance with Health Canada. It kind of depends on the project. Each project is different, and each one's go to different degree of sophistication. It depends on the size of the project. So if you've got a big pipeline or a road project, then they all have different types of criteria you can apply. So it kind of depends is kind of the answer.
All right, next question here. Can you provide guidance on how we can convince management when sound is below occupational limits, but still irritating or problematic for those who are affected? What strategy has worked for you in this type of discussion for an occupational environment?
I mean, it depends how low the level is. If it's occupational, I'm generally meaning that it's in an office environment potentially rather than an industrial setting. I mean, throwing the kind of WHO guidance at them to kind of show that levels below like around 40-50 decibels of an unoccupied office, you know, they start to have issues with communication. Open plan offices are a nightmare for this. This is one of the things that became terrible. It's not just the noise level, it's the acoustics level and people disturbing. So I would start to throw health guidance at management would be my first kind of response to kind of help you on your way. And that helps and works, and maybe get a consultant in just to come and chat with your management, just kind of or on the phone or whatever, just to kind of help them understand that just because it's not a really loud level that's causing hearing damage doesn't mean that it's not affecting productivity.
And we have a question here about whether the use of personal earplugs would be considered a control measure.
In my honest answer, no. Like if you're doing a hearing assessment, generally it's not really stated in the occupational thing, but in other places in the world, earplugs are the last resort. So the problem with earplugs is that if you're putting earplugs on somebody in an environment, it affects all sorts of things like communication, their awareness of alarms, noises, people around them. So it makes it actually more dangerous. So the best thing to do is always reduce the noise level first through engineering methods, make the sound sources quieter. Earplugs should always be the last resort. And actually, there's instances where people are actually overprotected by having earplugs on because they're just throwing them with really high performing earplugs. If you haven't done an assessment to determine if those earplugs are appropriate, you can actually be putting people in danger almost because you're making them deaf on a site basically, so they can't hear reverse alarms as well. And it's yeah, in my opinion, and that's generally consensus, is that earplugs are definitely the last resort and only use them where you've tried every single other kind of mitigation measure.
What is the best approach to set noise guidelines or limits?
Look at other guidance that's well received. Look at the Health Canada guidance. Look at the WHO information. Take steer from what actually influences and causes health effects. Just looking at initial bylaws can be useful, and like the Ontario guidelines tend to have a better range of it. looking at what causes health effects if you're designing policy and guidance is the way to do it. Not just blindly applying other bylaws, in my recommendation, has caused problems for jurisdictions that I'm dealing even with today. So just taking things blindly and not really fully understanding where these regulations come from, really fully understand why they are what they are and make sure that they're not out of date, the ones that you're comparing to.
What are some qualifications I should include in a request for proposal or quote for an acoustic assessment?
Qualifications, okay, in terms of Canada, generally if someone has an engineering status, so that's a good idea. If they have some kind of acoustics degree qualifications, masters, they tend to be the only ways of doing it. There's not an accreditation process for an acoustics engineer. I'm still accredited under my kind of the Institute of Acoustics, which is like a global acoustics organization from the UK, and they vet how long you've been doing the job and they vet your competency and you're kind of peer reviewed from other people. But that doesn't happen. You've kind of got the APEGA system here, which is probably the only equivalent thing. But if you're not an engineer, that becomes difficult. But it doesn't mean the person isn't qualified to do the job, but that's the only real thing you could probably rely on as a request if you wanted to go down that route of specifying a requirement.
All right, and we have some more questions here around the dB meters. Someone's wondering about the ones you can download on your phone and if those work well, as well as looking for some recommendations for some different models that you'd recommend.
Okay, so the phone ones, they're not too bad actually, but they're only really good for really loud kind of constant levels within a certain range. So they're okay, but they tend to be quite varying. You're probably better off if you haven't got the budget to throw out a serious sound level meter, buying one of these cheap kind of type 2 sound level meters that have got a cheaper microphone on it for like $100 or something. You're better doing that rather than relying on your phone. They tend to be okay, quite reliable. They don't give you the frequency content breakdown, but if you're seriously looking at buying a sound level meter, the range is quite crazy. There's a lot of different options out there, but go for a reputable brand. So there's Briel and Kjær, but they are generally one of the more expensive side of things, but they do make good stuff. There's Rion, they make good stuff. They're a Japanese manufacturer. There's you put me in the spot now. Svantec make good units. Larson Davis, yeah, they're good with units as well. So there's lots of different options, but ideally look for depending on budget, a Type 1 microphone, which is more resilient to being out in colder temperatures, which is ideal for Canadian climates. So getting that system in place that can cope with that. When you go to Type 2 units, which have less sophisticated microphones or less reliable microphones, they start to break down. So you would need that, and then you would need a calibrator to go with that system. But if anyone's looking to buy anything in particular, or just feel free to email me. It's a big discussion piece and depends. So.
I was going to say, Dan, we can take the people who've asked that question, and perhaps if you just write an email with those recommendations afterwards, just so they've got it all written down. Perfect.
Yeah, I can chat to them as well, no problem. So.
All right, our next question says, thank you for the great presentation. I am working with regulatory and sometimes I receive complaints about ambient noise. How can I eliminate the background noise to give accurate noise readings about the source?
Okay, so getting closer to the source is the only real way, or you do it during different time periods. So generally the nighttime, depending on where you are, I obviously can't just tell where you are. If you're near a road, it's obviously quieter then, or generally nighttime's quieter anyway. So you want to try and suppress the environment as much as you can. Moving closer and using a combination of modeling as well to kind of do that. That's not done as much in Canada. I don't understand why, but it's a technique used throughout the rest of the world to kind of use a combination of modeling and measurement to get kind of a middle ground, because the problem is, if you, like you say, if you're just measuring ambient noise, you're not really saying anything about the actual noise level coming from the source. So get closer to it, quantify it, then put that in a model and then kind of calculate out what that level will be at the receptor. And that's kind of the only real way you can do it if you can't suppress the ambient noise as far as possible and it still be a problem. So.
All right, our next question here is, could you tell us more about underwater noise and what type of projects would it be considered for?
Underwater noise, yes, I'm not a huge expert on it, but I do know a fair bit about it. So underwater noise is, well, it's propagation in water, but generally the sound sources are near the coast. So it'll be pipeline compressor stations, ships, generally piling operations for construction of wind turbines, those sorts of things. So underwater noise travels a lot further because it's a different medium. So there's air is, because it's a gas, it doesn't like transmit, it's less conducive to sound transmission. So it travels further, but the relationships are still very similar. The decibel levels are different because there's different references at play. But it's a very similar situation, apart from it travels a lot further. The mitigation is more difficult. We tend to use things like bubble screens and things like that to try and break up the waves and that sort of thing. So it's definitely a specialized thing. We have a specialized acoustics underwater team in SLR, but generally it's for ports, that sort of thing. We've worked with the Port of Vancouver to do things like that and help them do that sort of thing. So it's still important to monitor the background environment and the active environment. So I know that shipping companies are looking into trying reducing their noise levels. So doing monitoring underwater is one thing that we look at and help them do. So it's another topic altogether.
All right, so I've heard trucks now use the shh to back up instead of the beeping. What are some other new technologies in noise mitigation in Canada? Where can we read more about these emerging technologies?
There's a wonderful thing online. If you type Google online, it comes up with this website called Google. But I'm being facetious. What you should do is there's a lot of emerging documents. There's acoustics news websites that come out with all this sort of stuff. I can email a few links around with the presentation afterwards. There's a load of emerging stuff. On my Noisebuster show, we talk about that sort of stuff. We get experts in doing this, but look to Europe, if I'm honest. They tend to be further ahead on these things. They tend to be, because they've been nearer to people more with sound sources, nearer to people over a longer time. They tend to have these mitigation things in effect more. So Europe is leading this more, really. So look to that sort of area. The Institute of Acoustics is a good place to read. They have a bulletin that they put out about new stuff. But yeah, that's sort of a good starting point.
Do you recommend CNRC, NRC national codes to apply noise regulations to construction site regulations?
Yeah, I mean, they have their place, but it's like anything, it's situational. I think that they have their place, but I still think they can underestimate the impacts. I think that it's important to relate to health effects. I don't think we do that enough in Canada. I think we need to start taking that more seriously. The limits can be high. I mean, even in a lot of jurisdictions, we don't even refer to these things. We just kind of have operational time limits on things. We don't look at the actual sound levels that are coming from things. As long as we're doing it within a certain time window, it doesn't really matter. So I think they have their place, but use them carefully.
All right, and is there any guidance for conducting a noise baseline survey for EIA, such as locations, duration, or methodology?
Yeah, there's a bit of guidance out there. It's not. It comes from the the provincial regulations, though, more than anything. Health Canada has its guidance and talks about a little bit about it, but there's still not a consensus within the Canadian way of doing an EIA as to how long things should be, and it really depends on the source. So if you're doing an aviation project, you need to take into account all sorts of things like different wind directions, all sorts of meteorological conditions, different time periods, all these sorts of things. Whereas an industrial site probably doesn't need quite as much detail in terms of an EIA. So it really depends on what kind of project. I know that's a bit of a short answer, but it really depends. So I would recommend surveys for EIAs. That you're getting to a level of around a week, probably, I would say, for a reasonable infrastructure project, but they can be longer. Say if you're doing an EIA for a wind farm, you've got to get loads of different wind directions in many situations, and sound levels that associate to that. So we need to rely on the conditions, and often we don't get them when we want them. We kind of just have to sit and wait. So you get surveys for wind turbine projects that can last months. But doing them first and proactively is always the way, because the amount of times I've had to deal with it afterwards, where you've got the turbines in operation and you have to switch them off, and that costs so much money. Like, you wouldn't even believe how much it is to turn them off. So doing it all before proactively, and do it for as long as you can. Like, I'd say 1 to 2 weeks is a good survey length, really, for your kind of average, and then going longer for these more unique, like air and wind farm territory.
All right, we have time for one final question here. So can noise be a factor of real estate evaluation?
I don't think it comes up very much. Like, it's not really. We don't deal with it day to day. Like, we have like land designation things we do for like councils to make sure that it's not going to be obscene, but it's generally kind of a tick box exercise, and it's just checking that noise isn't ridiculous. It's really down to the owner, the purchaser, to do their due diligence to find out, like, i.e. ring roads being built near your house or them sorts of projects. But really, no, there's no requirement for it to be discussed unless it's been an issue in the past where you've had like a legal proceeding with the house. But I even think then that it's not a requirement. It doesn't need to be disclosed. It's up to you to kind of disclose it. So yeah, it's not a hard fast rule, unfortunately.
Perfect. Thank you so much, Dan.
No problem. Thanks everyone for listening. Appreciate it.
Thank you, Dan. Some great questions there, and I know there's a couple we didn't get time to answer. We've gone slightly over time, but please feel free to either reach out to Dan, but we will put those questions to him and ask him to respond after the session ends. And I think we just have a couple more slides I just want to run through just before we send everyone off. But a big thank you to Dan and the SLR team. It's been really great to hear from you today. And yeah, please do reach out to Dan if you have more questions. Before I let you guys go, I just want to tell you about some stuff we've got happening at Eco Canada over the next few months. So we're doing a lot of virtual training and events right now. Obviously, COVID makes face-to-face interactions really difficult. So we're hosting a virtual career fair November 25th. Attendees, we're expecting about 1,000 attendees from all across Canada. And it's a chance to kind of, as an employer, to hopefully meet your next employee, share your current job postings and share information about your company. As an attendee, it's a chance to hopefully do some networking and meet some great, hopeful future employers. So there's information on our website, or please reach out to me at events@eco.ca if you're interested in either attending or being one of our lovely employers. Next slide, please, Dan. We also have some live virtual workshops happening. So these are brand new for this year, and it's custom real training that happens in a virtual setting. So you get 4 1.5-hour sessions with a leading facilitator. You get all the benefits of a face-to-face workshop, so breakout sessions, activities, homework, and actual FaceTime with the presenter in a virtual setting. So it's a really cool way to get that training and fit it into your day-to-day routine or your work-life balance. And we have our next workshops happening on November 3rd, and it's all about writing proposals and grants. So it's a masterclass on how to effectively write those proposals and grants to help you secure the funding that you need. I think I have one more. Just to thank you again to Dan and SLR for today's webinar. Thank you for everyone for dialing in. And just I mentioned that our next webinar is happening on October 28th, and it's going to be all about Indigenous cultural self-reflection and cultural sensitivity training. And it's one of my lovely colleagues here at Eco Canada, Brad Spence, is going to be delivering that free webinar. And it's just been Orange Shirt Day this week, which is a day to kind of remember the suffering from residential schools in Canada, and it's a great opportunity to learn a bit more about Indigenous awareness. Absolutely free. Check out the eco.ca website if you want more information. I want to thank you all for dialing in today, and please do let us know if you have any questions, and hopefully we'll see you again at a future webinar. Thanks so much, everybody. Bye now.